Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. I'm going to start by writing out all the outcomes. So I'm going to start with trout. So for trout, as a main, I could have had biscuits for dessert. Trout as a main, I could have had cheesecake for dessert. Trout as a main, I could have pancakes as a dessert. Then I'm going to move on to a curry for main. So for curry for main, I could have had biscuits, could have had cheesecake, and I could have had pancakes. Now, to work out the probability, it's the amount of successful outcomes over the total amount of outcomes. So successful for this is a curry and pancakes. So curry and pancakes is a successful outcome, so it's just one. The total amount are 1, 2, 3, 4, 5, 6. So the chance of me picking at random a curry and pancakes is 1 over 6. We've got to first of all find out what the y-intercept is, and the y-intercept is just where our line hits the y-axis. So the y-intercept, which we sometimes can call C, is 11. Now, what's that 11? What unit is it? Well, it's 11 pounds, because our y coordinate, our y-axis is in pounds. But what does that mean for the taxi company? Well, how many miles have been travelled on the y-axis? Well, 0. So at 0 miles, we've had to pay the taxi man or woman £11. So we know that therefore the taxi costs £11 at the start. We'll just leave it at that. Okay, so the initial charge, or the cost for the taxi turning up, is £11. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. The question asks us to find the bearing of Adrift from Billstown. So we're at Billstown and we're looking at the bearing of Adrift from it. So we're looking at this angle here. And so to find that angle, all we need to do is 360 degrees, which is angle at a point, and then take away the 39 degrees that we know, and that equals 321 degrees. And the reason why we find this angle is that all bearings are from north going clockwise. So the answer is 321. To find the average rate of petrol usage, which I'm just going to call rate, what we're going to do is we're going to get the distance travelled by the car, and we're going to divide that by the amount of fuel used. So the volume of the fuel used. So the distance was 135 kilometres. The volume of the fuel used was 9 litres. We do 135 divided by 9, which is 15. So it's 15, and this was in kilometres, and this was in litres. So it's going to be 15 kilometres per litre. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that, and so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. To go from meters to centimeters, we obviously times by 100. But to go from meters squared to centimetres squared, we times by 100 per dimension. Now, whenever we talk about things in meters squared, we're talking about areas which have 2 dimensions. So we times it by 100 squared. So when we've got a 2 meters squared here, we times by 100 squared to get it into centimetres squared. So that's going to be 20,000. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And a and b are the parallel sides. So these ones are the parallel sides. And the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160. Take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get a integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together. 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. So the distance initially travelled is going to be 14 kilometres for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometres travelled. So in total there has been 28 kilometres travelled. It's important to remember our speed, distance, time triangle. So we've got speed equals distance over time. And here we are given a distance because from here we're 16 kilometres away from home. So the distance, let's just draw another triangle, the distance will be 16. And we're told that the speed is 32 kilometers per hour. So the speed is 32. So to find the time, we're going to do 16 divided by 32. So the time is a half an hour. And half an hour would bring us, if we start here, half an hour would bring us to 2030 because it's 8 o'clock where we start and we end, therefore, half an hour later. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it'd be A squared plus B squared equals C squared, but this time A is 39. B we are given as 47.148, we've just worked that out, and we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X squared. And we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to X. It says it wants it to 2 decimal places, so that would be 61.19. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going, and we go through Devley on the way, so we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes, or 0.75 hours, and the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject. So we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we just go expand the brackets, 7m plus 70. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the a and the 1, which it suggests in the question. Then I'm going to work out the a and the 2 as a different combination, a3, a4, etc. Then I'm going to look at the b and do the same thing, b1, b2, b3, etc. Then I'm going to work out the c, so all the combinations with c. So how many combinations are there with a? Well, there's going to be 7 because there's 7 numbers. How many with b? Well, there's also going to be 7. And how many with c? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. First thing I'm going to do is just draw the square out. And we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. It doesn't look like it, but we actually have a quadratic here, and the reason it doesn't look like it is because we don't have an x term, but as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets, and you square root the first term, well, that's just going to be x, and you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we're just going to quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. I'm going to first of all draw the two triangles out separately. And we've got A, B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides. So these two angles are the same. Got exactly the same thing on this side. We've got F angles, so these two are corresponding. And then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15. And that will tell us what CE is, which is 45. So our answer is 45. Whenever we're asked to compare two box plots or two cumulative frequency graphs or a cumulative frequency graph and a box plot, you're always going to be comparing two things. You're going to be comparing the median and the interquartile range. Now if we do a little table, like a good table, and we've got male and female, and we're going to work out the median, which is the first thing we have to compare, and the interquartile range. And it can actually just be the normal range. We don't need to pick the interquartile range. So the median for male is this line here, this bit here. And if you look down, that is 22. And for females, it's this one here. If you look down, that's 18. And we just go write a sentence. So you say something like the median is higher for males, brackets 22, always show your values, than for females, brackets 18. Okay, easy. Next we're going to do interquartile range. Interquartile range is slightly harder because you need to do the distance between the upper quartile, which is this line here, and the lower quartile, which is this line here. And so that would be 24 take away 19, which would be 5. And for the females, it would be 28, which is this one here, take away 16, which is this one here, and that would give you the answer of 12. So the next sentence we say is the interquartile range. They don't mind you writing IQR, that's absolutely fine. Is, now you can say lower for males or higher for females. I'm going to say lower for males, brackets 5, than for females. Bracket 12. Now, the median is basically on average. On average, the males are higher. Okay, so it's just an average. Says on average they're higher. The interquartile range is an interesting one. Anything to do with range is about consistency. So it's actually quite good in many instances to have a lower interquartile range because it just shows you're more consistent. So you say the sentence could be that the males are more consistent because the interquartile range is lower. Generally speaking, the higher the median, the better. The lower the interquartile range, the better. Apart from if you're talking about things that like the time it took you for a race, you kind of want the median to be lower. Still, you want the interquartile range to be lower because you want to be consistent. I'm going to start by labeling this triangle, and so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be the way around, so I could have 5s plus 4 over 13 plus s, or anything like that. We're going to first of all multiply the coefficient of the x squared, which is 6, with the number on its own at the end, which is minus 5, and that will give us minus 30. And the special thing about this number is we're looking for two numbers that times together to make that number, and we're looking for two numbers that add together to make the coefficient of the x, which would be 13. Now, to make a product that's negative, we know that they're going to have to be different signs. So one will be positive, the other will be negative. And we can do this in our head, or we can write out the factors. So I can just quickly write out the factors of minus 30. So it would be minus 1 and 30, minus 2 and 15, minus 3 and 10, minus 5 and 6. And then the same thing, just the other way around. So 1 and minus 30, 2 and minus 15, 3 and minus 10, and 5 and minus 6. And we're looking for the pair of numbers that add together to make 13. So just looking down the list, this one here will make 13, won't it? Because minus 2 plus 15, or 15 take away 2, is 13. So the two numbers we're looking for are plus 15 and minus 2. I'm going to rewrite the question now, but instead of the plus 13x, we're going to split it up into the plus 15 and minus 2, or the other way around. So we could do 6x squared minus 2x plus 15x minus 5. And a little tip, if you've got a positive and a negative number, let's just tidy that up a bit. Always put the negative number first. Okay, so always, if you've got a choice, put the negative number first and then the positive number. It just makes the maths a bit easier. We're going to look at the first two terms and the second two terms separately. We're going to factorise them linearly, which means just put them into a bracket. And we'll only look at the purple box. So here we've got 6x squared minus 2x. So that's obviously going to be 2x on the outside. And that's going to be 3x minus, and here it's actually just going to be minus 1, isn't it? Okay, and for the next one, we're going to have, was it 5? And that would be 3x, and again, minus 1. Okay, these two brackets, it's not a coincidence they're the same. They have to be the same, and we just write them once. They are one of our brackets. If they're not the same, it means you've made a mistake somewhere. And we get the 2x and the plus 5 together. So 2x plus 5, we put them together. So in total, we have the first bracket, which is 2x plus 5, and the second bracket, which is 3x minus 1. And actually, the brackets can be either way around. Okay, so first thing I'm going to do is just a quick sketch of this diagram. And so we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here, which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total. And they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here, so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2, we're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2, and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k. 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176, and then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. To answer this question, we're going to do something a bit weird on the calculator, and this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going, and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. So the first thing we need to realize is that we can create a right angle triangle from within this cone. So if I draw a line from the top going downwards, a line to the right and a line up, and we can label the sides. So we've got 30 here, and we've got 10 at the bottom here, and we're looking for this angle here, which we're going to call y. And if I just highlight all of this and move it across, then we're obviously going to be using trigonometry to find out what y is. So first step with trigonometry is, well, find out where the right angle is, which is there. And the one opposite the right angle is the hypotenuse. The one opposite the marked angle is the opposite. And the one between the right angle and the marked angle is the adjacent. In this question we're not using the hypotenuse because there's no letter or number next to it. And so I'm going to do my SOHCAHTOA, SOHCAHTOA, and we're not using the H, so we'll cross out these two. We're using the TOA, and that stands for tan the angle, which in this case is y, equals the opposite, which is 10, over the adjacent, which is 30. And so tan, so we're going to inverse tan both sides, so we're going to have to solve this. So let's get my lines in. And we're going to inverse tan both sides. So that will just leave y on the left hand side, and then we need to find out what the inverse tan of a third is. And the inverse tan of a third is 18.434 blah blah blah. Now, what I did at the start was I moved the diagram away from the cone. Let's just move it back and we'll see the fact that y is exactly half of x, because we've done a line straight down the middle. So to find out what x is, all we need to do is double y. So x is going to be 2 times y. So that's going to be 2 times the 18.434 blah 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 blah. And so that is going to be 36.869, etc. And it says it wants it to correct 2 decimal places, so that's going to be 36.87 degrees. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.